And with that, let's get started. Please welcome Dimitry.
Hello, everybody. Hopefully you can hear me well. So I've been introduced. My name is Dimitry, and I just want to say that my opinions are my own and do not reflect the views or opinions of my employer or its products. Anyway, so this talk is about webhooks, but before we get to that talk is really about a way to escape or provide bidirectional delivery of content.
Sorry, guys.
Thank you.
Try again.
Better? Yes, better. Thank you. Hostile networks, monitored networks, censored networks, and the escape is to your external host under your control, your command and control servers, or wherever the case may be. The focus is on proxy, more specifically content proxy, and that's what we're going to talk about today. So the audience is for, the talk is going to be from the red team perspective, but obviously red teamers, pen testers, defense folks, and privacy advocates are definitely welcome here. So before we go into, thank you. Oh, much better. Before we go into the details, we'd like to set some stage for the strategic goals, the technical goals, and the tactical goals of this talk. And so we're going to seek alternative means of effective outbound communication through content proxies. We're going to maximize adaptive retooling capability for exfiltration, and we're going to try to minimize our discoverability by elevating our OPSEC. And last but not least, we're going to use the opportunities that we have inside the organization to do so. The tactical goals, we are going to try to do reverse connectivity to the environment. We are going to do asynchronous communication to your CNC, and we're going to try to avoid censorship with this technique. The technical mechanism will employ webhooks concept, and we're going to go over that. We are going to do this in asynchronous manner, and we're going to showcase a tool that will automate that. So to set the stage, we're going to talk roughly about the offense, defense, red and blue. The content proxy is the central piece of that talk. Command and control is your C2. We're going to introduce the concept of C2 broker. And we're going to have two players, two agents, one the client and the other is the server. So the problem of communication from restricted networks, it's really not a cat and mouse game. It's more like a game of a red elephant and six blind blue men, just like in an old tale when six blind men would touch an elephant. They would not know who that animal is, but they would touch the trunk and they would say, okay, well, that looks like a hose. You know, they would touch the body, they would look like a wall, and so on and so forth. So essentially, the red elephant is you, the pen tester, the red teamer, somebody who's on the inside, and the blue man are the sensors, are the mechanisms for defense, and that's what we like to think of this specific situation. So from the blue perspective, you know, the blue men need to identify what this unknown entity is. Really, how blind is it? What capabilities it has? How can we better restrict the movement of this elephant, right? How to detect capabilities without revealing our own? And basically, it's just a matter until the unknown moves. Then we're going to have sensors, it's going to be passive, and it's going to be good, right? But from the red perspective, the game changed to the opposite. What is this unknown environment that I'm in? How quickly can I, quickly and safely can I learn what it is, and how really blind are the sensors? I'm not exactly sure. This is my first time in the environment. And my wish is that if I sit tight, if I don't move, then the sensors will go away, and I'm going to go on doing what I was doing. But in reality, the rat has to figure it out on his own. The elephant has to figure it out on his own. And so the challenge here is that the elephant has to move. But unfortunately, the first move may kill, right? If we're focusing on a proxy, you need to bring your tools into the environment or do whatever you need to do here. So touching proxy in unsafe manner in quiet environments or restricted environments is a challenge. So the three outputs from your move as an elephant are the unsafe negative outcome. We're going to talk about that. The safe negative outcome and a safe positive outcome. How does this play out? So unsafe negative outcome, right? You're done. You're pretty much, you're in the environment, you're discovered. You're burned and you're done. Now the safe negative outcome, from the red team perspective, you can probe the environment and you can tell when it's hostile, right? You've got the idea sensors, you've got some of the tunneling that is prohibited, you got tight content proxy, and you've got no domain fronting or any kind of online drives that you can reach. You're pretty much constrained, but you're still alive. You're still on the inside and you're trying to figure something out. You're just buying yourself some time. So the safe positive outcome from this is going to be when we've convinced the blue that we are good, right? So the blue operates on some opinions, I would say, right? Depending on what sensors they have, what processes and procedures they put in place, is that, they may discover that you're just an approved tool or you're a safe protocol that that is allowed through the internet, through the intranet out, or you're going to an allowed site, your traffic is deemed safe. On the other side, the mechanisms are being trusted, right? The blue mechanisms are being trusted. There's a whitelist that the company may have, and so you're golden that way. Or you've got in an environment where only known bad is being watched for. So that is a safe positive outcome when you are able to blend in. So, but really, if you think about that, the last two outcomes, the safe positive outcome and the safe negative, suffer from a few issues, right? They are both built on assumptions of trust for sensors or trust for your own tools that are available to you and the environment that you're in. So both the red and the blue can be paranoid about each other's capability. They would sit tight, not move. Or they can be dismissive of each other's capability. I bought this really cool product. It works. It's going to be a silver bullet for me. So from the red as well as from the blue perspective, you need to understand that the map that you've built with your probes is not the territory, it's just a map. So what you need to do is, as a red elephant in this case, is that even in very restrictive situations, you need to break static map of the world that the blue built for you, or you've built in this environment. You need to meet blue at their map of the world. You have to blend into the traffic, you have to blend into business process, and so on and so forth. And you need to do pace, and you have to pace and lead them. That's what we're going to talk about. So how do you achieve this sort of pace and lead and being safe really in the environment that you don't know? It's akin to mimicry, right? Where you resemble a specific animal or a plant, or in this case protocol, or some feature or mechanism, and you just blend in. So for the red, you need to be an approved business need. You can be an approved traffic or protocol, and you need to use good tools and valid rules, depending on what the company is considering to be. Now, the static map of the world that the blue has built is based on that whitelisting, is based on this content proxy rules, it's based on the known bad that they see. So, in any given company, you would want to take this business process and you need to follow that. Now, in this case, we're going to look at the developer. We're going to follow the developer through the organization. We're going to code red tools in the developer process, and we're going to hide in plain sight of the developer process routine, right? So we're pacing to lead, and the way we lead is that we say, we are the developer, you trust the developer, so you should trust us. But more importantly, we're going to reach the strategic goal of meeting the defense at their map of the world. It's all good and well, right? But we're in a very hostile environment, and we have a tight content proxy. There's nothing you can do about that. In certain environments, some things are being taken care of really well. How do you work with this? We'll diverge a little bit and talk about webhooks. So webhooks is a new technology for asynchronous web responses. It is being used on the internet a lot. It's making its way to the enterprise just because developers are social animals. They code open source tools and they use it and they like it, and so they obviously bring it back to the enterprise. It has really good, interesting capacity for collaborative and social coding updates. It runs over HTTP, which is great for us, and it uses the HTTP protection mechanism or transmission mechanisms. So to talk about webhooks, let's step back a little bit and talk about how the server request works in HTTP world, right? We all know that we submit a request for processing to the web server, then the server starts executing it, and we are asking the server every second, less than that, more than that, but more or less we're going to look for a response from the server by probing, asking the server for a response. And so the server has some issues with switches, contacts, right, resources. The server gets overloaded, maybe not, but on a scale, it might. And so when the server is the result, the client grabs it. That's the old way of doing that. The webhooks is a little bit different concept. It's really of the response subscription. So the web server says, okay, well, stop asking. I'm not going to be able to respond to you. Why don't you give me a URL, the endpoint where I'm going to post my response once I'm done, right? It's asynchronous subscription. The server executes the request as it did before, but the client is doing something else. It's not polling the server, and then when the server is ready, the response is being posted. That's asynchronous way of communicating back to the client through the webhooks. How that's implemented is it's very easy, right? It's a link that you provide to your client resource on the internet, and it's a REST, right? It's a REST resource, and the server says, hey, I'm going to register you, and when I'm done, I'm going to post to your IP address and the port and the resource, the request that you have, or response to the request that you have. So webhooks are being used everywhere now. Continuous integration, code repository, Slack, anything that has to do with monitoring of your network for events, for any kind of notifications and alerts. So it's cool, but we're still here, right? How is webhooks technology helping us in the context that we've outlined before? So let's talk about the C2 broker. What if we can find a allowed site through the draconian policy on the content proxy that we can actually communicate with? I mean, any business has to do business online, so there are some sites that are completely whitelisted, and you can just go and browse them, right? We can turn that site into a broker using the webhooks. So essentially, we can drive the data and communication over that C2 broker to our external site through the webhooks. So we're still keeping the big goal in mind of classifying ourselves as something known good to the business process that the defense has. We're going to go into details in this, but this is the general architecture for our technique here. We're doing a request to some C2 broker, which is going to store our request and forward it to the C2 on the other side. The C2 executes it, posts it back into the website, that the C2 website, and then we're going to go and pull the result. How that works, we're going to see in a minute. But before that, what constitutes a good C2 broker? Like, you can't pick any site on the internet because they have to support webhooks, and they have to be allowed, right? They also have to be public. They need to have decent setup of webhooks API. They need to be allowed and look normal to what the company is doing. And they obviously need to be allowed through the proxy. Again, coming back to the webhooks, we're following the developer, thinking back to the environment and saying that, well, I mean, the developer uses exactly the same thing, right? The sites that we're talking about are Heroku, GitHub, Slack, any kind of notification sites. They may be really good candidates for C2 broker. Let's speak on GitHub. So GitHub is very popular. It's pervasive in enterprises. Developers use it, infrastructure folks use it. Anybody who is pulling any kind of code will probably be pulling it from GitHub at the moment. From our red perspective, there are tons of advantages. It's developer friendly. We can code against it. It is extensively used, allowed in enterprise and through the proxies. And it has OPSEC features, right? GitHub makes our life easier by encrypting our communication, making it more secure. But the last point is very important because developers adopt it. So you have great chance of GitHub being used inside of the organization and not go anywhere. So Octahook is a GitHub C2 broker toolkit that is going to use GitHub to do all these transmissions, right? It's going to try to broker GitHub. We're turning GitHub into a broker for our communication to our external entity. We're going to register Octahook server through the webhooks, as we talked before. And we're going to use Octahook client to send requests to the server through the GitHub. So first things first, when you get to GitHub, you have a very nice set of API, right, as we talked about. You need that for your communication. The payload URL is what your client is going to be receiving. This is the URL. The format that is going to receive it in is a JSON, and then you activate the hook, right? So once that's done, you can subscribe to I want to say a dozen events or types of events off of GitHub, but you really care about issues and comments. That's how Octahook is going to drive the transmission of requests and receive the responses. Now, the OPSEC part, minimizing the exposure and blending into the environment, is we're going to ride on GitHub's great way of securing our communication with HMAX, and you've got certificate that has been validated. So your content proxy is not going to intercept that unless, and if it does, then we'll know about that. So great features for us. Now, this is the sort of the guts of how these things work. Every agent on the inside, your client is an agent, and your server on the C2 is an agent. But the agent on the inside and the agent on the outside, they both have identifiers. It could be anything. In this case, it's probably like 8 to 10 character configuration string. And then, so those agents are posting issues on the GitHub, just like a developer, right? We're trying to blend in. We're opening up an issue on a repository that we're gonna store our request in, and we're communicating the responses back from the C2 over the state of the issue, which is closed, open, and also the comments for the data. So you can see a developer going in from the defense perspective. You see the developer going into GitHub, opening up an issue, typing something in, and then they might have comments, right? Very normal. Uses the Git application tokens, so you can actually toggle through your configuration here. Now, this is the example of what what that really is the GitHub submission of issues and comments. Now, so we have a one-way directional communication, right? Can we make it better? Because we need to still go and pull the GitHub for our execution, for our details. What can we do? Well, it turns out that on GitHub, you can configure multiple webhooks, up to 20. So guess what? You can do bidirectional communications, a broadcast of your responses and requests to all the parties talking. So that's a real-time shell through the GitHub to both the client on the inside, the agent, right, and the C2. So essentially, you're doing real-time communication over GitHub, and that's your shell through the proxy. This is the example of how you would configure that. All you have to do is just create a different URL for your client. And then you can start playing with roles. You can have a server, you can have a command client, you can actually create a pretty elaborate configuration where you would say the client on the inside is going to post commands and the server is going to respond to that. Or you can flip it around, right? You can actually say, if you have two directional communication, that the external host is going to be the requester and the internal host is going to be the executor of the request. So thereby it's your shell back. So clients and servers are configured in configuration file. We're going to see this. Now on to the demo. So when we go through this, we're going to see asynchronous unidirectional command execution, the first example, where the request goes through C2 GitHub and then gets executed on the C2 server. We're going to try to turn on the real-time communication mode to do the both ways, bidirectional. We're going to look at execution of commands and put in the content, because sometimes you need to bring the content, content back into the environment. So servers and clients on both sides load from two configuration files, right? The server and the client, they can have similar features, but essentially this is the client. You're sitting on the inside, and what you're going to do, you're going to execute a command, and when you do that, this command goes to the C2 over GitHub. You're executing a ls command. Nothing happens, right? Because now is the first case where you need to pull GitHub for the answer. So you check issues. And when you check that, you see that the C2 actually says, I'm done. Here's the response. I closed the issue, right? And then what I'm going to do, I'm going to look at the issue and get the response back, right? That's the first one. That's all executed through the GitHub. The next part is we're going to turn on bidirectional. We're going to start the thread that is going to go both ways. We're going to do exactly the same thing with ls. And we're going to receive the command right away. So we're achieving the bidirectional communication here. There are some commands in this octahook that is released today, just for convenience, but mostly is for putting content through C2, through the broker into GitHub, and so you can actually grab it and execution of the commands. That's the file put, right? So when that happens, you can be sure that, well, we're just simulating that we're touching the file on the C2 right now. We're going to write something into the file on the C2 side, and then we're going to bring it back through the GitHub to us. So that's the execution of the content on the other side, and then we're putting it back. Right. So the Git transfer, we touched a little bit about on that, but essentially this is the demo of how things are put together through GitHub. You've got the command, and you've also got the response, if there is any. And then while we're looking at this, we can start thinking that, well, that's normal, right? Developers, no defense is going to look at this right now and say that it is something that is not used. So Everything is logged, so you can actually see centralized logs on your clients, on your agent and the C2 if you want to. And you can actually expand this to create different commands. It's a plugin-based architecture. The configuration is, time permitting, we can go into this, but essentially what that is just a YAML file with a bunch of configuration stanzas to connect to the GitHub and how to drive the execution, also to assume the roles. All right, so the client and the server configuration is very, very similar because you can actually toggle the roles here. So right now it's cross-platform for the most part, except for the command execution because it uses POSIX. So your C2 might need to be a POSIX machine. It is extensible with command plugins. It's one process with embedded web server and the command server. So when the defense goes and sees it, they just see a process, a user process without anything else, no forks or anything like that. But what we really want to think about what's going to come next with the 20 hooks. For example, this is GitHub, right? You can implement that across Slack or anything like this. The concept still works. The webhooks work exactly the same way as you go. You just need to write a different plugin. But so we want to do swarming capability. We want to probably do the follow the sun. For example, if your C2 gets burned, you can actually send your requests to a different C2 somewhere, right? Or maybe even 2 or 3 internal agents somewhere. We can reassign the direction, and we can reassign the roles. Who is the requester? Who is the responder? And we can also send it to a specific agent in the future, right? If you have multiple C2s, we want to send it to this one or that one. So defense and mitigation. Webhooks are here to stay. There is no way. I mean, it's too good for developers. It's just very useful. So if you're on the defensive side, make sure you restrict your laptops to go to specific sites that the users need to. Not everybody in your organization needs to go to GitHub or to Slack. That is a less sexy approach, of course, with group policies or whatnot. But this is the way that is going to sort of save from that perspective. Save. So the content proxy is not going to be in the way if this scenario is used because your GitHub is allowed. So make sure you're taking care of this on the endpoint. And then from our red team perspective, we're going to continue writing social coding, and the more times developers give us the way for to execute, we're going to take advantage of that. This is the GitHub repo. If you want to work on it, or just check it out, please do. If you have any questions, let me know, please. Thank you.